Sup guys, here's Sebastian from Flowin, and in this video I'm going to show you a little about this application and the internals of it, which uses it's a small Flowin experiment we did in a weekend and a half a day, more or less. It's a nice application that it was more like a proof of concept for real-time web and new things we can do with browsers and internet. So it's powered by, in the front end, by Amber, and in the back end by Pharo. So here we have Amber. If you don't know it, go ahead and take a look. It's pretty cool. You click, for example, here, and you got the development environment right in the browser. You can start coding and hacking it and have a workspace there. Unit test. It's pretty cool. So that's in the front end. In the back end, it has Pharo, which is a clean Smalltalk, open source, very nice, very dedicated people to make the community behind to make it really good. We are using in Pharo this piece of software, which is Zinc. It's a HTTP server, and it's supporting WebSockets since a while now, and it's pretty good. We are also using MongoDB for storing our objects. We're using the JSON serialization and storing it and refine as objects. We are using MongoTalk from Pharo to connect with Mongo. It's also a very good library, and we're using Willfy to make a whole bunch of code and serve it through the web in a nice way when you use it. So it loads pretty okay. It's very acceptable in the response. It can be better, but it's right. It's good. It's good enough. You can use it. So let's see how it interacts. For example, when you put two browsers and you point both of them to tasks, flowinconcept.com, you will see it's loading in each of them, and it's getting all the tasks. And when you click on one here, it's reflected the state on the other side. When you click on the other side, in the other client, you will see the change populated. So it's interacting. For example, even if you change the content of one of the tasks, you will see it here, and you will notice the change here is instant, but in the other side it has a little delay, like that, like that, like that, like that. So that delay is a round trip of around 600 milliseconds or something, which is going all the way from South America to Europe, where the server of this application is, and back again down here. So you have a round trip that's going from South America to Europe and South America again. So that's the delay you are seeing here. But beside that, everything is real time. You can drag it and you see it responding. So if you like, let's see how the internals of doing something like this with Amber and Pharo is happening. So let's go ahead and take a look first. Where do I have the local part of these guys, right? So in these tabs, I've set up this local host and this port, and here to point to the local development version of this application. So let's go ahead and take a look to the folders. The folders are here. This is the folder, the root folder of this. And what do we have here? Oops. What do we have here is the, oh, sorry. Here we go. The art, the static content, the VM for Pharo. In this version, in this software, I'm using Pharo 2, but that's because we did it a while ago. And worker 1 and worker 2. Actually, I'm not using worker 2. And this is a script image we can safely remove. Okay. Worker 1 is the one I'm using. Here is the image of Pharo, which I have open here. And here's where I develop. In SRC, I have the file tree source code load, which you can access with Monte Carlo browser. And this project is named Reactive internally. You set up like this repository, file tree, and you tell in file tree you tell source like that, and you have there all those packages. All right, there. So here they are saved. Oops. Again, here. And why worker 1 and worker 2? Because I like things being able to scale horizontally, right? So if we need more load, we put another worker and everything should go smoothly. I also have here a MongoDB running. It's nothing fancy, you just run Mongo. It has some, it's Redis, but it's not being used in this project. This is the VM again, and here we have some handy commands to deploy. Actually, the one is uglify. Let's take a look at it. Uglify will clear, concatenate, and uglify all the GS that is here. Concatenate is going to generate this file, and that it's being easily processed by the uglifier, which is going to leave a nice file ready to be served on by the HTTP server on the server when you publish in production. So that's one thing. Another thing is you have the index here. You have the development version of the index. It's different because one is going to load. It's going to load differently. One is for development, another is for production. The production, for example, has the Google Analytics stuff, and the development version has everything that it's needed by Amber, by the development environment, which you don't need in production. So everything is bigger in the development version, and in the index you have, well, for example, here is Google Analytics, and you have one file with all what you need for the application here. And what I use is a little number to version it, so it can be safely cached once every release. So let's go take a look at how this can be seen from here. I have here, this is the workspace of Amber. Let me copy this line, and let's query the description to this guy. if we inspect, let's make it bigger. Let's start for the front end. So if we inspect this earth task, what we're inspecting is the model of a task. So what we see, it's an object, an earth task, that is having in data a JavaScript object that is not going to print as a Smalltalk object, but it has self as JSON string. It has some content. Yeah, you can see it could nicely serialize. Okay, so but here in Smalltalk you can ask them things like is completed, for example, and it will return. If you print self, you can say description, and it should give you the description. We are talking to this guy. Yay. For some reason it's printing strange. Let's reload, but I don't want to lose this workspace, so I'm going to copy all. I'm showing you this because this might easily happen to you during the development cycle, so it's safe to we need to open the IDE. I left here kind of hide in the dev version. I left an icon, a link reacting to open the environment. So let's paste now. So where will we this description, yay, is complete, true. If we mark it to incomplete, it's going to incomplete, tell us that is false. And if we change the content, it's going in description to give us a fresh, nice content. So it's preserving state, you can see that. I'm doing the interaction manual, so there is the human delay here between this action and this, but there is no delay in this front end. So once you change the state here, is instant that you get the response here. What is not instant is to the server side, but let's have some fun now interacting to the server side. Oops, there is a hole there. Why there is a hole there? I think it's something older. Is production false? Okay. Yeah, it's an old connection. No, it's safe to close. So let's go ahead, and I have a bunch of code here, but what you see is, what you should care is this one. Let's clean up a little. Let's make in a new workspace. Let's take these two guys. What is this? Mongo pool is our connection to the database. We want to use reactive and ignore the rest. And in ODB we have some verbs. One of them is the main for using it all the time. It's like this generic thing for evaluating a generic block. Do. Inside of it you can operate things that are going to be read-only or read-write. So, but you can only write if you are inside of a do operation in a Mongo connection. So if I evaluate this and print, it's going to find that task. So if we, for example, let me get it in one line to make it nicer. Let's copy in the next line and selecting parentheses and telling, for example, the description. I'm going to see the yay, yay. All right. So what happens now if I change it to yay with not so much enthusiasm? So we have it like that. So it's changing. What we are seeing is that it changed in the local and it changed in the server. And when we say it changed in the server, if we look in the database, it's going to carry a fresh version of this object is there, yay, and with a lot of emphasis. Yay is here locally. Oops, wrong button. Sorry about that. Yay. Here in the server side in Pharo, yay, and of course in Mongo. If I refresh, whoops, why it's not refreshing? Let me. That's a little Mongo Hub bug. Tasks, double click and run, and here we go, yay. So let's go again, check everything's in order. Description, yay. Pharo, yay. Mongo, this time, yay. So you can change the state. We can use that with every part of the object, right? True. If it's not, let's say is complete. True. Right, and now it's complete. False. So all nice, but you can do that with anything. You can do that with a post, but the fun part is that you can push things. It's not only the fun part is that the whole thing is full duplex. Let's put it there so we can see both clients are reacting to that. So what about changing things from the server and seeing them in the clients? We have some of that. Let's take a look. We can do this here. We can take a task, send the message, be complete, save the changes, make the object to publish that it has changed. So let's first get this task in that variable so we can handle it like this. We can put it task equal so we can store it. So I'm going to evaluate, and the variable, if we inspect it from Pharo, we will see it's there and it has all the attributes that is stored by Mongo. This JSON object is stored by Mongo. So let's go ahead and make it incomplete. Evaluate, and we have it published. Let's make it complete, and we have it published. So we can do that also with the description. We can change the description to something, I don't know, description, yay, with one exclamation mark. Oops, wrong key, and evaluate. So you can see if it's all the time reacting full duplex. You can do it one side and from one direction and the other, and publish any state. I'm using for that something also that I'm not showing here, but it's being used by Reactive, which is this mapless thing, which is helping me to store easily and get the local version of the models and the remote version of the models. I can read from with a callback with Ajax. I can post. I will verify the JSON and get the object, or I will get the verified version from the local store. So, for example, if we see in the resources here, we will see that the local storage has all these objects, which I'm serializing here in JSON. In another application, I'm using something that is cryptographing everything here. But for this one, it's nothing critical, and you can put safely like that. It's actually an ODB, so there is a route, and you navigate from there. But you do that directly on here, like inspecting the objects. You can do it here. You ask for one to for example, you ask for the list to tell you what the tasks are. That's one nice thing I can show you quickly here. So we get the list and we put the ID of the list like that, and we get, oops, again Command P now, it's Control P here. So we get it there. But if we ask for the tasks, we get the tasks. We get an array of IDs that we can iterate. But I think we don't need to iterate. I think, if I don't remember wrong, the model here, the list, in the instance side, no. Okay. But it's easy to add something that, let's say, like, for example, let's do it. Get tasks. So you do self tasks. That is going to give us the ID, right? Collect each an ID. That is going to be an ID. R task. Load local load at an ID. Control S is going to save, and let's inspect this list, and we are on a list. Self get tasks, and there we have an array of tasks. We can inspect them, and each one can tell us an ID. Self collect each ID. Oops, ID is not defined. I forgot to who. I should tell ID to each variable. There we have it, or we can ask description and inspect, and we have the descriptions of them. So yeah. Okay, so you have an idea. That's how you get it in from the local store. I'm using that. The rest is on the server side, and the server side also have a version of these mapless things. I'm probably publishing somewhere in GitHub. This mapless for Mongo and Redis are nice guys. It helps you to you can take any of these mapless objects you can persist in Mongo. You can tell them whatever you want, in the sense that they don't have instance variables. They have a JSON object and they throw everything there, whatever you put it there. So for example, let's say something they don't understand. Let's inspect the task and be sure that they don't understand something new. So actually they don't understand, don't have the message for description, but if you ask for it, you get it. You can tell the, I don't know, owner, this user, alright, I'm evaluating, and we don't have here the setter, self owner print. So, and if we refresh here, we will see it, owner. So that's handy for making it easy and quick. You just save it in the, like this, in the database, and you're good. After that is you can use Mongo to accommodate indices if you want to quickly to query fast for some attribute, but you can have fun with that yourself. So that's it for the video. If you have questions, feel free to send me an email. Let me show you an email here. And tell me how it goes. Tell us how it goes. Show us more real-time stuff. It's the fun thing. People like to interact with technology, and this is really a possibility to make a change on that, making applications less stupid. We are probably going to see this a lot more in the future, and if you know how to do it, cool things with Amber, I will love to hear about you and how you work and how you prepare your stuff to deliver. Have fun and keep in touch. Bye.